Hello, 7th graders, and welcome to Lesson 7. Today we'll be discussing how to divide fractions and also mixed numbers. And we're going to start with a little bit of vocab today. And our vocab word for the day, the most important one, I think, is the top one there, reciprocal. Okay? And the reciprocal is one of two numbers. I'm going to abbreviate. Whose product is 1. So in other words, when you take these two numbers and you multiply them together, you'll get an answer of 1. And I know that's a little bit weird to think about maybe when we're talking about fractions, but let me give you an example. One reciprocal, so if I had the fraction 3/4, its reciprocal would equal 4/3. We took the numerator and we put it in the denominator. So 3 went to 4, and took the denominator and put it in the numerator. 4 went up to the numerator. Okay. Another example. Let's say I had. I'll give you a little bit trickier one. Say I had 2, and I asked what is its reciprocal. Okay. Well, the first thing you'd want to do is make this into a fraction. So you can make any whole number into a fraction by putting 1 under it. And so its reciprocal now you'd put 1 as the numerator and 2 as the denominator, would be half. Okay, basically it's just a fraction flipped, all right? And why does that equal 1? Well, product is multiply. So if you were to multiply, let's try these two, 3/4 and 4/3. 3/4 times 4/3. Well, 3 times 4 on top would be 12. And 4 times 3 on bottom would also be 12. 12 divided by 12 is 1. So you can see that that's where they get this definition. Okay, if you had, let's just try another one. 2/7. What is the reciprocal of 2/7? Well, just flip your denominator and numerator. So it would be 7/2. Okay, hopefully you're getting the hang of it. The next vocab word, multiplicative inverse, that's kind of a tricky word to say, is just a fancy way of saying the reciprocal of a number. Okay? So you might hear that fancy term saying, take the multiplicative inverse. All that means is just find its reciprocal or flip the numerator and the denominator. Okay? The way I actually remember how to divide fractions is I use an acronym, KFF. Okay? And KFF stands for keep, flip, flop. KFF. Okay? And that's the easiest way for me to remember, rather than trying to remember reciprocal and multiplicative inverse and all this other hoopla. I think KFF is most simple. What that means is you keep your first fraction the same, you flip your division to multiplication, and you flop this second fraction to its reciprocal. Okay? So again, keep. Okay, we kept the first fraction the same. Flip your division to multiplication. And flop, change this fraction, the second fraction, to its reciprocal. So the reciprocal of 2/5 would be 5/2. You make the denominator the numerator and the numerator the denominator. Okay, so in other words, multiply by the reciprocal of 2/5. So we have 3 times 5 and 7 times 2 on bottom. So now it's just, you might be saying, so when you're dividing fractions, you actually just multiply them? Yeah, you multiply by the reciprocal. There's actually no real division involved, which is kind of nice. Because like we saw last section, multiplying fractions isn't all that hard. You take your top number times your top number, 3 times 5 is 15, and your bottom number times your bottom number, which is 14. So our answer is 15/4, or if you wanted to simplify that, 14 goes into 15 one whole time, and there's 1 left over, and keep our denominator. Okay, so there you have it. I would recommend KFF. I think that's the most simple way to remember, but you choose the way that works best for you, right? Let's try KFF for letter B, and I'll kind of show you how I like to write it out down on the bottom here. So I have 3/8 divided by 12. And right away, since 12 is a whole number, I like to write it as a fraction, just so I'm dealing with two fractions. And then I write KFF above my statement. Keep the first fraction the same. Okay. So 3/8. Flip division to multiplication. And flop 12 to its reciprocal. Well, the reciprocal of 12 over 1, okay, if I were to change that, it would be 1 over 12. Right? And that's just what I showed right here. So 3/8 times 1 over 12. And then, yeah, we're multiplying by the, again, reciprocal is that fancy word of changing numerator to denominator and denominator to numerator. Okay? Before I multiply across here, I'm going to look diagonally and see if I can simplify. Yeah, 3 and 12 have a common factor of 3. Dividing each of those by 3, I'd get 1 and 4. Okay, now I can multiply right across. 1 times 1 will give me 1, and 8 times 4 will give me 32. So 1/32 would be my final answer. Okay, well, let's flip the page and see what's next. All right, example 2 now, we are dealing with mixed numbers. So you can see that we've got a whole number with a fraction. And, excuse me, the trick here is to just rewrite your mixed number into an improper fraction. Okay, to do that, we take our whole number times our denominator. So 5 times 3 would give us 15, plus 2 would be 17. So this is 17/3 divided by 1 times 4 is 4, plus 1 is 5, 5/4. So we are writing our mixed numbers as improper fractions. Okay. Then from here, do KFF, keep flip-flop. Keep the first fraction the same. Flip your division to multiplication and flop this to its reciprocal. So that would be 4/5. All right. Again, multiply by the reciprocal of 5/4, which is 4/5. Okay. Multiplying straight across now. I don't have any common factors when I look diagonally, so I can't simplify first. I'll just multiply. 17 times 4 will give me, I'm going to have to pause the video here for a telephone call. Okay, sorry about that, guys. That darn Mr. Terpster was calling me about some basketball updates, so sorry for cutting you off there. Let's see if we can't pick back up where we left off. I think I was talking about how 17/3 times 4/5 was going to give us our answer. Okay, so I'll take 17 times 4 on top. 7 times 4 is 28. Carry my 2. 4 times 1 is 4 plus 2 is 6. So I get 68 over 3 times 5 is 15. And I'll change it to a mixed number. So 15 can go into 68 4 times, which would be 60. And we'd have 8 left over to get to 68 and keep my denominator of 15. Okay? Let's go ahead and try letters B and C, and let's do them the same way. Okay? So for letter B, I've got 3/4 divided by 2.5. I'm going to change 2.5 into an improper fraction. So 2 times 2 is 4, plus 1, this would be the same thing as 5/2. Okay, so improper fraction. And so that would give me 5/2. And then multiply by the reciprocal. And in other words, K, so the reciprocal of 5/2 is 2/5. In other words, KFF. Keep 3/4 the same. Flip division to multiplication and flop this to its reciprocal. All right, so I've got 3/4 times 2/5. If I look diagonal, I see that I have a common factor of 2 here. 2 divided by 2 is 1. 4 divided by 2 is 2. And then I'll multiply across. 3 times 1 gives me 3. And 2 times 5 gives me 10. So 3/10 would be our final. And for C, now I got to change my first number, so change 5 and 5/8. Write that as an improper fraction. 5 times 8 would be 40, plus 5 will be 45/8. And then keep, flip, flop, keep this the same, flip division to multiplication, and make 5/9 into its reciprocal. So that would be 9/5. Okay, I can simplify before I multiply. So 45 and 5 have a common factor of 5. 5 divided by 5 is 1. 45 divided by 5 would be 9. So on top, I'll have 9 times 9 giving me 81 over on bottom. 8 times 1 would be 8. Rewriting that into a mixed number, 8 goes into 81 10 times, which would be 80. We'd have 1/8 left over. All right, hopefully you're getting the hang of it. Flip to the back side for the last example. The lifespan of a golden dollar coin is 30 years, while paper currency lasts an average of only a year and a half. How many times longer will the golden dollar stay in circulation? Again, whenever they ask how many times, you're referencing, that's a key word for division. Okay, so we've got 30, or we'll take the coin divided by the average for paper is a year and a half. So we have, remember, you can write it as a whole number by putting 1 under it. That's what they did here. And then they wrote 1.5 as an improper fraction. And then again, KFF, keep, flip, flop. Keep 30 over 1 the same. Flip division to multiplication and flop this to its reciprocal. So that becomes 2/3. You can simplify diagonally here, dividing each by 3. So 30 divided by 3 is 10. 3 divided by 3 is 1. Multiplying across, 10 times 2 would be 20 over 1. Same thing as 20. So the golden dollar will stay in circulation about 20 times longer than paper currency. Wow, a lot more durable, that's for sure. But you sure don't see many golden coins out there, do you? Okay, for finishing up, please pause the video, practice 1, 2, and 3 on your own, and see what you come up with for your answers. All right, keep 3/5 the same, flip to multiplication, and make 1/2 its reciprocal, multiply across. 3 times 2 is 6, 5 times 1 is 5. or same thing as 1 and 1/5. Keep first fraction the same, flip division to multiplication, and first I'll make this to its improper fraction. 5 plus 2 is 7/5. So its reciprocal will be 5/7. Both of these are divisible by 5. And multiply across. 3/7. And lastly, average life of a queen ant is 3 years. The lifespan of a worker ant is 3/7. How many times longer, reads you division, will the queen ant live? So 3 over 1 divided by 3/7. Keep the first fraction the same, flip division to multiplication, and make the next number its reciprocal. Simplify, divide each by 3, you get 1 and 1, and multiply numerator times numerator, denominator times denominator, would give you 7 times longer the queen will live than the worker ant. There you have it. That is 3.7, dividing fractions. Remember KFF. That should get you a long way. Let me know if you have any questions of any sorts, and I'll do my best to help. We'll see you next time.